Last chapter, was kind of our big focus was quadratic trinomials. Like last chapter is all like doing all the math things with them. So we had a bunch of steps. We did a lot of algebra. Think of this as kind of the opposite end of that, where we're gonna do a lot more of the graphing, a lot more of kind of the features of a quadratic. And that's all today is. We're just gonna focus on 4 different characteristics of a quadratic function or a quadratic graph. We're going to start by doing just some vocab, some fill in the blank. So a blank is a nonlinear function that can be written in the standard form y equals ax squared plus bx plus c, where a is not equal to 0. This is just a quadratic function. So anything that's a quadratic was kind of our fancy word for to the power of 2. And remember, a function is just like an equation, right? So if you want to do like a little arrow, something that makes something a quadratic is that it's to the power of 2. So this, we've looked at a lot already. This would be our quadratic trinomial. One kind of important piece why we state specifically that a cannot be 0. Math definitions are super precise. Because if let's say our a term was 0, 0 times whatever x squared is going to cancel it out. This term will go away. So then if our x squared isn't there, it's no longer a quadratic. We would just have an x on there, so it would just be linear. So a has to be 1 or more or less than 0. It cannot be 0 exactly. Else it's no longer quadratic. Quadratic functions make a unique type of graph. They're what we call a U-shaped, like a normal side U, or kind of an upside down shape U. That U has a specific name. It is called a parabola. It's spelled P-A-R-A, then B-O-L-A. A parabola. A quadratic. It's what the x squared is what makes us have that U shape. And you'll see that more as we start graphing these. The lowest point on a parabola that opens up or the highest point on the parabola that opens down is we have the word vertex. So then think of vertex as kind of the maximum or minimum value. When we say it's a parabola that opens up, that means kind of the opening or the valley shape is pointing upwards. So look like this. That is something that opens up. And the vertex would be the lowest point of that. So where it kind of changes from decreasing to increasing. We see if we were to be on this line, if we were to start up here, as we're going down, we're decreasing, decreasing, decreasing. Once we hit our vertex, we're kind of not moving at all. But once we pass our vertex, we start moving up. So sometimes we'll call it the vertex, the point of change. If we say it's opening down, so if it's the highest point, opening face versus a frowny face. So that's a terrible looking parabola. So this would be an example of a parabola opening down. In that case, that makes our vertex at the top of our graph instead of at the bottom. So this is open up. This would be open down. And all these vocab words are important, so when we're talking about features of our graph or I'm explaining steps later on in the chapter, we know what I'm referring to. We have kind of a shared language that we're using to talk about these. Last piece, the vertical line that divides. This should be not that. divides the parabola into two symmetric parts this is a longer series of words. It's called the axis. So AXIS of symmetry. SYMMETRY. So axis literally is the word for a line. In geometry, you'll talk about that a lot more, so as a sophomore. But this means like the line of symmetry. If something's symmetrical, it could be like split into half evenly. So if I was to fold the paper and it was to fold it so it's on top of itself, and I put a crease in it, we would call this crease could be like our axis of symmetry, where we could fold it in half and perfectly overlap each other. If you look at the problems that are just the first two on your front side, you could see, kind of imagine where that line would be, so you could fold it on half so one side is on top of the other. So we're just going to go through these, and we're going to pick out these four characteristics. We'll label them on our graph, and I'll also put the labels to the side here, so they'll be in two places. So vertex is usually just you don't have to, there's not a particular order to start with this, but vertex, if we look, this is a graph that's opening up, so we're looking for a lowest point. So our vertex would be down here. Vertex. And we want to label the point that is. So remember, we always put our x value first, then our y value. So this will be 1, -9. Our axis of symmetry, we usually draw, you'll see most of the times with kind of a dash line. To find your axis of symmetry, you just have to go up and down vertically through the vertex. Again, just imagine this as the line, like the crease of your paper if you're going to try to fold this graph in half, so one side was on top of the other. So since it's a line, we want to write it as an equation, so not as a point. To write something as an equation of a vertical line, we talked about this like back in chapter, 3 maybe. It's an x equals, and then you're finding whatever value you pass through on your x-axis. So you pass through a +1, so our equation for our axis of symmetry would be x is equal to 1. Another way to find the axis of symmetry, it's always going to go through the x point of your vertex. All right, so this is 1, this is 1. If you don't put x equals and you just put 1, that is wrong, because there's a lot of 1s on this graph. Everything here could be a 1, everything along this side could be a 1, so we need the x equals. That's you saying it's a line. All right, axis of symmetry is a line. We need it to be an equation. Our next points, zeros or x-intercepts. We're more familiar with the name x-intercept, so where our graph crosses our x-axis. Zeros means the same thing. All right, zero, these two are synonyms for each other. I like to use both. So just be comfortable with that. To find our x-intercepts, again, we look our x-axis. We're finding where it intersects at, and there'll be two of these. One x-intercept, or 0, will be right here. And we're going to give it, again, a point, 4, 0. And then our other point would be where our other side of our graph. So -2, 0. You most often write these as points as well. Again, we don't want to get into the habit of just writing -2 and 4 because there's a lot of 4s on this graph. There's a lot of -2s. So having them as points is the best way to do it. So -2, 0, and 4, 0. Sometimes there will only be one x-intercept, so it just touches your graph and starts going back up. There'll be some cases where it doesn't touch your x-axis at all, so we have no zeros or x-intercepts. Last one, y-intercept, is probably the one we're most familiar with. We did this a lot when we were just graphing linear lines. Your y-intercept is where it crosses your y-axis. So your y-axis is your line that goes up and down. So this would be the point 0, -8. That's your y-intercept. And y-intercepts always start with 0 because we're on the axis. So a lot of these pieces will come into play later. Like we'll talk about why these are called zeros and how they relate to what we did last chapter. Vertex is important because that's how when we go through our graphing process, that's the point that we'll start with. And y-intercepts can tell us things as well about kind of our trinomial that we start with. A lot of interconnectedness between this chapter, last chapter, and what's on the graph. So the rest of these are just kind of practice. If you want to try doing some on your own, go ahead. Otherwise, just keep following along. I'm going to do the same order that I found them last time, doing my vertex first. This time our vertex will be what we would call a maximum value because it's the highest point on our graph. So it would be the point -2, +9. And then to find the axis of symmetry, again, I'm just going to draw a vertical line, that goes through my vertex. So I see it crosses my x-axis at -2. So I know my equation has to be x is equal to -2. My zeros, or my x-intercepts, again, in this case, we have 2. One of them we have 1, 0. The other one would be -5, 0. Again, the best way to write them is as points, making sure you're doing x and then y. So we have -5, 0 and 1, 0. So now our y-intercept in this case will be on the positive side of our graph. So up here at 0, 5. Stay in the middle, we just go up 5. I think for sure I'll just do one more together with you. You can kind of check once I'm done. You already did it. You did it correctly. This will be, again, opening up. So our vertex will be a low point on our graph. So it would be the point 3, -4. Make sure we're having that x point first. My axis of symmetry, I'm going through the x point of my vertex, so it's x is equal to 3. Going to my zeros over here. We have 5 comma 0 and 1 comma 0. Then our y-intercept would be 0 comma 5. We're in the middle and just going up 5.